So this morning I went down to Hyundai Park and I did the range tests for the RF24L01 device using the GPS, the NEO-6 GPS module. And I've come back with this CSV file. This is what's generated from the actual programs which I wrote, which are in the last video. And all the source code is on GitHub now as well. So if I open up this file, so this file is formatted so that it can be loaded into Google Maps and it plot points on Google Maps. So in order to do that, you need 3 columns, or at least 3 columns. There's other ways of importing data as well, but this is the easiest way. So my first column is, I've called it a label. And then if the second 2 columns, if you call them latitude and longitude, then Google Maps will know what they are, and it will predict that you want to use those for coordinates. And in my label column, I've just put down the miles per hour, which the GPS is measuring. So it puts it in a thing called, I think they calls it ground speed or something like that. And then you have to format the longitude and latitude. Now that's what my source code actually puts it into this format. This is what the Google Maps accepts as longitude and latitude format. But all you have to do is take the CSV file, which is created from the actual source code, and you can just upload it straight into Google Maps. You don't need to modify it at all. And so I've plotted points every 5 seconds, so I've got quite a few points in here. And you can, it doesn't matter for Google Maps, you can upload thousands of points. So if I close that, and if I go to my browser, and this is Google Maps now. My virtual machine screen grabbing will probably trim in the side of this a bit, but if you go to google.com/mymaps, and then on the left there's a button called, if I just reduce the size of this browser bit here, that's better. So on the left, there's a top left, there's a button called create a map. So if you click on that, and then what you can do is on the left it says untitled layer, and underneath it says import. So if you click on import, and then you can select a file. So click on select a file from your device, and then just select the file which is generated from the source code, and it will upload it. It'll automatically Google Maps automatically recognizes longitude and latitude as the labels, so you just click on continue there. Then on this one, click on label, and then click on finish, and that will load up the points into a map. And so here it is. So you can see the points in the middle. So if I just zoom in on those points, it's going to be a bit slow because I'm screen capturing at the same time. So these are all the points that I captured on my trip this morning. So what I did was, so the reason I've got all these points is that this isn't my range test, not all of it. So when I got into my car this morning, what I thought I'd do is I'll put the GPS receiver on the dashboard, and I'll record the trip, my entire trip. So on my passenger seat, I put the receiver of the RF24L01 receiver, and the transmitter and the GPS receiver was on the dashboard, and it captured all these points as I drove. So if I zoom in, and just to get an idea of how good the GPS receiver is, so there's some points now where there's gaps. Now I'm not sure if that was the GPS receiver or the RF24L01. I think it's probably the RF24L01 which was missing some receptions. But if you click on any of the points, it will tell you the label is the miles per hour that I was doing at that particular time, and you can see it keeps track on the road really quite well. So I'll just zoom out a bit to make it a bit quicker to navigate. So this is where I came down into Hyundai Park over here. You can see where I got out of the car, and I went and took my tripod, which had the receiver on it, and I placed the tripod up here. So I'm at Hughenden Park. There's plenty of open space around. I've tried to pick a space which is in the middle of some clear, and I've got my GPS receiver on a tripod, which I've placed here. I'll leave that in that static location, and I've got my transmitter and GPS receiver in my hand, and I'll walk up and down and I'll get some GPS readings and find out where the transmissions stop and get a range for this transmitting device. And then I walked across Hughenden Park until over here it seemed to be losing the signal a lot, but the thing about the RF24L01 is that it will retry on errors, or at least my program, if it fails, it will just skip it and go to the next and try again. And so the longer you leave it at kind of distance, the more likely you are to get like an eventual sending of a message. But it was breaking up at this point over here, and you see I moved across here and over here. Then I lost the signal. I probably went behind a tree at this point because I think there was a tree in the middle of the park. But I tried to do another field of view return, walking back and coming up this route, but there's a big gap there where I think I must have been behind a tree or something, and then I came back up to the top here. So what you've got like a little ruler here, and you can measure distance like this, and so between the points it's about 310 meters range I was getting. Now you probably get a bit more than that. So, but if that's the radius, so the diameter of the range is probably about 620 meters. But this was on a level field, line of sight as well. I could see the tripod, although it was very small in distance when I got to about 310 meters. So it was all line of sight, and it was a clear day. The atmospheric seemed good. But I might go out and retry it again on another day with different atmospherics and see if I get the same kind of results. It'd be worth having a couple of results to do some comparisons to. But that's what I was getting, and that doesn't really surprise me that much, because when on the night before I did this test, I put the transmitter in the window of my house. I went for a walk up and down the road. And because it's like all built up area and there's cars parked in the road and stuff, I got about 160 something meters in radius. So this was about twice that, wasn't it? I think with line of sight, it's getting about twice that. So this is probably is the kind of range that you get, I reckon, with clear line of sight. And in the built up area, I was getting like 160, 170 meters. So that's a good result, and it's nice. It is good to test the GPS as well and see how accurately it follows the roads on my journey.